As we have observed the impact of the pandemic on the way people work, we've seen a massive shift of people working from home and also working in hybrid work situations. And as we observe this, we've been able to use digital telemetry to actually measure an organization's health by looking at the network collaboration patterns between individuals. Now, I should note that when we do this, we always do this in a way that is an aggregate, and we do this in a way that is privacy preserving. One of the first steps in understanding how an organizational network works is to look at the underlying data structures that support it. And the data structure that we use to understand organization is called a graph or a network. Now, to understand a network, it's first important to take a look at how they are constructed. On this slide here, what we can actually see on the left-hand side is a list of what are called edges. This gives you a source node and a target node and denotes that the two are connected. On the right-hand side of the slide, we can actually see a visual depiction of this edge list that represents then the corresponding graph that is output from this. To show you the power of how a graph might be useful, let us consider the use case of looking at co-authorship networks in a scientific conference. So in this dashboard here, I'm going to go ahead and select a particular author and look at other authors who he has co-authored with at least 2 times. And from this, we can now start to extract a graph or a network of interest. If zooming in on this, we can actually see that particular author, and we can see all other related authors that are around him. Now, you may note that in this particular analytic, you'll see nodes of different colors. That is actually determined here using network machine learning to understand which groups of people are more likely to collaborate with one another. So in this particular case, we can see that this author is likely to collaborate with several of the different author groups in addition to the main group that he's collaborating with, which is highlighted here in red. Graphs are very important because they help us understand not only just the data around what's happening, but also the connections and the depth of those connections as they cascade across the graph. So when you take a look at a graph like this, it's not just showing you that, hey, this person's connected to one person. It's letting you dive deeper and look many hops down to understand how those relationships and those deeper network collaborations might form into something more meaningful. One of the first problems you'll start running into, though, when you start using graphs, is that the problem that is depicted on this slide. So on the left-hand portion of the slide, we actually have a graph, and it's a lot of nodes, and they're just laid out all in one little area. But the problem here is they're not organized. We have, on the right-hand side of this slide, we have the exact same graph, except here we've actually visualized it in a meaningful manner. We have used neural networks and network machine learning to lay this graph out, to do the coloration, and then to do the positioning and the sizing of all these nodes. And once we do that, we can actually get a much better sense of which nodes might be more related to one another than other nodes in the graph. And so this kind of gives you a sense, almost like a map would, of where the regions of the graph might be interesting and which regions might be co-located or next to one another. So now that you understand how important network layouts can be for helping visually debug the network you're working with, let me introduce you to a new tool that we've developed and now have open sourced called Graph Drill Down. In this tool, it actually runs a series of network machine learning steps. But first, we have to drag the data on there. So I'm going to start first with the vertices. These are all the actual nodes. And you can see the individual nodes now with no edges or links in between any of them. Kind of looks like a starscape. Next, I'm going to drag the edges on. And when I drag the edges on, you can immediately get a view just like the one I showed you on the previous slide. It's kind of a jumble of nodes. It's a giant hairball, and you can't make any sense of it. So how do we make sense of this? Well, by clicking that UMap layout over here on the right-hand side, what it's actually doing is I've now kicked off a series of network machine learning processes. The first process that we are going to run is called a Leiden-Hierarchical community detection. And what this will do is it will look across those nodes and find nodes that are more likely to be connected to each other than to the rest of the graph. It will then bundle those up together and put them into a single cluster and then start coloring the entire graph by cluster. The next thing it's going to do is to run a neural network-based graph embedding algorithm. Using those embeddings, we can then actually do some down projections using UMap, and we can use some layout procedures to actually generate a layout that you can now see on the screen. So now, on this version of the graph, we can actually start to see there are clusters of activity with similar color sets. For example, there's an orange cluster over here on the left. There's some green clusters down here, and we can get a sense for how the clusters are connected, as well as the interconnections within those clusters. So now that we've seen how we can actually build network layouts and understand the collaboration patterns around a particular network, let's move to one of the next most common tasks that we encounter when we're looking at graphs. and that is the task of ranking. Let's say you have a graph as shown here on the left, and in this particular graph, you have the challenge of trying to find another person who has a similar communication pattern to another person. So you're trying to make a recommendation that maybe this person A should be talking to person B. Now, the task of this is very difficult if you just take a look at the graph by itself. Because if you're looking at this graph and you're measuring distance trivially, say for example by the number of hops it takes to get to the other person, it turns out that the entire graph is about 2 or 3 hops away. And you can't really differentiate between nodes that are the same number of hops away. So if you say Jim is being recommended to Bob and Bob is 2 hops away, but Jim is also being recommended to Marcia and Marcia is 2 hops away, you have no way to differentiate the distance between them. And this is where graph embeddings really come in. Graph embeddings allow you to look at the full latent space of the graph, because what it does is it takes each of those vertices and it creates a representation of that vertex into what is called a high-dimensional tensor. Now, using these high-dimensional tensors, we can actually represent each of those nodes quantitatively in a high-dimensional space, and in this case here, I'm going to go ahead and down-project it into a 3D space. This just goes to show that we can actually calculate measurements between any pair of vertices in that original high-dimensional space, which we can then use to perform the ranking. So now that we've taken a look at how we can use graph embedding to perform ranking operations, let me introduce you to a few new metrics that we've developed specifically to better help understand organizational health and analytics. The first metric I'm going to introduce you to here today is called freedom. Freedom is a metric that lets us understand and compare the formal organizational hierarchy as derived from human resources and compare that to the actual observed hierarchies and work groups that are observed from the informal communication structures of people just working. So to give you a quick example, if you have a group that has very, very high freedom, that is a group that is probably working across the company. So you might have an engineering group that's working with marketing, sales, finance. That group would probably have a lot of freedom because those people are working with other people that are not necessarily in their hierarchy. On the contrary, if a group has very low freedom, that means that they're really only working within the confines of that HR-defined organization, and they're not really collaborating with people outside of that group that is very close to them there. The next metric I'd like to introduce you here today is called fluidity. Now, fluidity is called Omni, if you take a look at the graphical logic library that is backing this. But what fluidity helps you measure is how much a person's network changes over time. So, for example, if you have a developer that's working inside of a core team that's not experiencing much change month over month, and they're just talking to the same people at the same volume every month, they would have a very low fluidity score. If you have someone, for example, who is reorged into a completely different organization, and now they're talking to completely new people, that person would have a very, very high fluidity. And so this allows us to actually measure this change over time based on the network collaboration patterns that are observed. So with these metrics, we've been looking at how has COVID actually impacted the way people work? How have their organizational networks changed? So for that, let me show you this image here that actually shows a definitive change that we actually observed across COVID. This is looking at about 4,000 different organizations and looking at the siloing score behavior, which is actually a function of a company's modularity, and looking at the modularity before COVID and after COVID. And what we see is that once companies shift to a work-from-home posture, they invariably shift to a much more siloed posture, as you can see here on this chart. And so there's a very noticeable statistical effect that we can observe from the effects of COVID. So now that we've seen how COVID has affected these network analytics and these measures of organizational health, let's put it into practice and show you how we've actually deployed these capabilities into products. In this next demonstration here, I'm going to show you Viva Insights, the Azure Templates Organizational Network Analytics feature. In this tool here, we've loaded up a fake company where all the nodes in here are completely fake and there's no personal information in here. And we're going to look at some of these network metrics to analyze the health of this company. So for this company, the first metric we're going to look at is called workgroup stability. This helps us understand the work groups and how much those work groups change over time. So if you have a high stability, that can be good, but if it's too stable, that might also give you indication that you might want to have those groups collaborating more with others. Now we can also click on this, and when we click on it, it'll actually color each of the nodes by their fluidity, which gives you another sense of stability. So you can get a sense for understanding how much each of those nodes are changing over time in their network communication patterns. The next tab that we're going to look at here is called network silo behavior. And what this measures is the modularity and the siloing nature of each of these groups. So when I select this, it will start showing you which groups are perhaps at risk of breaking away and becoming too siloed. And you might want to get them connected up with other groups to help remediate that. The last metric we have is called employee cohesion. And this metric helps you understand within a 2-hop neighborhood what's the connectivity that we're observing. So for example, if I'm talking to Jim and I'm talking to Marcia, what are the chances that Jim and Marcia are also connected? If they're connected, that leads to a higher employee cohesion, and if they're not, that leads to a lower employee cohesion. Now that I've shown you how we can use these metrics to better understand organizational analytics, let's turn our attention to how we can use these analytics to actually understand what's going on in the world. And for that, I'm going to use a snapshot of a chart that we had built for the Work Trends Index for the 2021 release. And in this, we can actually again see that siloing behavior across thousands of organizations as it skyrockets as COVID strikes and then starts to wane, but never quite returns to the pre-pandemic normal. So with that, let me leave you with a few resources that I think should be very helpful. The first is the Graphql Logic GitHub Toolkit. This is a library that helps you perform a lot of the graph embeddings and network machine learning shown throughout this demonstration. The next is Viva Insights. Viva Insights provides a turnkey capability to deploy a lot of these capabilities directly on top of organizations to better understand what's going on within your organization. The third resource I want to provide to you is the Societal Resilience website, which provides you a very good overview of a lot of the other efforts that we're trying to tackle using these types of machine learning techniques. We hope that you've enjoyed this content on organizational analytics and resilience, and thank you for watching.